All right, this chapter is getting long, so let's blow through this one. To be honest with you, this is a very short video because I don't understand the point of this test. It's sort of, anyway. So it's called the nth root test, and you might notice this looks a lot, pardon my French, crappier than other formulas we've seen. It's got this absolute value in it. It's got an nth root of all things. So you might think that the time you'd use it is when the limit you're taking, like the formula, has an nth root in the formula, like in the sigma notation. But it turns out, no, what you're actually going to do is take the nth root on purpose. So just like in the ratio test, you sort of took the limit of this crazy ratio, or if you had the limit comparison test, you would take the limit of b over n over a of n, a sub n or whatever. In this one, you're going to set up a limit problem and take the nth root for like no reason. You're going to take the nth root of the formula you're given. Sounds crazy, sounds illegal, algebraically speaking. It seems ludicrous, but nonetheless, it's a theorem that a lot of books and a lot of teachers present, so we got to look at it. But I think you'll find it sort of annoying, sort of useless, and you'll probably never use it again unless a problem actually says use the nth root test. And most books, it seems like, even chunk it in with several other theorems in the same section, because it's like they couldn't even come up with more than a couple of problems that were worth using this on. So what we're going to do is we're going to sort of concoct. Someone will give us sigma notation with an a sub n formula, like n over n to the whatever, and we're just going to take that formula, put it in absolute value signs, and then take the nth root and take the limit. And then, as usual, 1 is sort of the criteria we're looking for. So when we get that limit, if it's less than 1, the series converges. If it's bigger than 1, the series diverges. And if the test is inconclusive, if you get the answer of 1 out of it. So the only time I can figure out that this actually is a test that makes sense to use, that might be faster than other tests like the ratio test, is in the case where you actually have something to the nth power. Now, this one is pretty obvious. It's not quite a geometric series. This one's really easy to do with the comparison test. It's really easy to do with the ratio test. But it's like tailor-made for the nth root test. So remember, this thing told us to take the limit as n approaches infinity of the nth root of this. And technically the square root around it, but I'm sorry, absolute value around the formula here, but since n is positive, there's no way this could be negative. So what happens when we take the nth root of something to the nth power? They cancel, right? So you end up with a limit as n approaches infinity of 1 over n, because the n here cancels the whole root out. And of course, the limit of this as n approaches infinity is 0. So you can see that that was really fast, like magically fast almost, for this crazy situation where we had an n exponent. The nth root cancels that nth exponent, and we end up with a really simple limit problem. So you can see how fast and easy that was. But like I said, you can also do this problem with comparison test. The only one we couldn't use was the ratio comparison test, I think. But it worked great with a ratio test, so it's like, ugh. Tailor-made, huh? So here's another one. And this one again is screaming out, hey, use the nth root test. Because you'll see there's this power of n hanging over the whole problem. And even though if that n weren't there, it would be a problem just like we did with the ratio test video. But because that n is sitting up there, it sort of makes things more complicated and crazy. So again, maybe this is the one time that you'd want to use the nth test without being told to, the nth root test. But this is a very contrived problem, right? It's very crazy, and it has this exponent of n being the giveaway that maybe we should try this. So we're going to take the nth root, natural log of n, over n. Oh yeah, and all this is raised to the n power. This is such a nasty looking problem. I mean, it's like the only way to use this is, okay. Anyway, so because we have this nth power and we have this nth root, those magically cancel each other. And we end up with a limit as n approaches infinity of ln of n over n. Now this limit isn't like super obvious, so I'm going to use L'Hopital's. So I'll just take the limit, the derivative of the top, which is 1 over n, over derivative of the bottom, which is n, which is 1. So this is 0 over 1, which is just 0, and that satisfies the nth root test for convergence. All right. So I think that was probably the shortest video I've ever shot for this website. Awesome. It's like this chapter is so long, it's good to get a short one under our belts. But the moral of the story is, as you can see, very contrived problems. And I guess the thing to look for would be that if you have a crazy formula with a power of n in it, this can help to simplify things pretty quick. But in almost any other situation, you'll never see this. So if you have a power of n, either up here or down here, it can counteract that, obviously, and make it quick and easy.